Here is a classic problem called the Monty Hall Problem. Behind one of the three doors there is a car, and two of the doors have nothing behind them, and you choose a door. If you choose the door behind which there's a car, you win the car. So once you choose a door, the game show host, let's say you chose this one, the game show host opens one of the doors that has nothing behind it. Let's say he opens door C, which is empty. I'm going to write E. The question is, now he asks you, do you want to stick to your door A or you want to switch to door B? The question is, is it better for you to switch to door B, or it doesn't matter, or you should stick to door A? This is the classic Monty Hall problem. One of the two doors here has a car behind it and the other one is empty. So most of us who thought about the problem, worked on it, know that you're better off to switch, and we're going to explain the math behind it. Let's say you're not going to switch, and let's find out the probability that you will win a car and the probability that you will lose or will not win a car. Well, that's very simple. If you decided that I will not switch, you know that the probability that you'll win a car is 1/3, because you will land on the car only 1 out of 3 times, and you will not land on the car 2 out of 3 times. So that's easy. So let's say you've decided you will not switch. So the probability that you're going to lose your car or not win it is 2/3, and the probability that you'll win your car is 1/3. That's very straightforward. Now let's see what happens if you say, okay, I am going to switch no matter what. Let's find out the probability that you're going to win. Let's find out the probability that you're going to lose. Okay, so this is not what we are looking at right now. We're going to assume we're going to switch. Alright, so let's say you are going to switch. What's the probability that you're going to lose? What's the probability that you're going to win? Okay, so let's say you land on the car the first time around. 1 out of 3 times you're going to land on the car, and the host will open one of the doors that's empty, and if you switch, you're going to lose your car because you already had your car and you switch to the other empty door, so you're going to lose the game. So 1 out of 3 times you're going to lose because of the switching. Let's go over it once again. There is a car behind one of the 3 doors. You're going to land on the car 1/3 of the time. So if you play this game 3 million times, only 1 million time you're going to land on the car. And if you are a switcher, the host is going to open one of the other doors, and there is another door that's empty, and you're going to switch to the empty door. You're going to lose your car. So essentially, if you switch 1/3 of the time, you're going to lose. 1/3 of the time you're going to lose. And that's what this is saying here. Now, what's the probability that you're going to win if you're a switcher? Well, of course you can see that has to be 2/3, but let's do it from scratch. So you're playing this game 3 million times, and you're going to land on the empty doors 2 million times, or 2/3 of the time. So let's go over it once again. If you play this game a large number of times, 2/3 of the time you're going to be landing on the empty door. The host will open the other empty door. So the door, if you're a switcher, you're going to switch to the car door. So 2/3 of the time switching will help you win. Let's try it once again. You're playing this game 3 million times. Out of those 3 million times, 2 million times you're going to be landing on one of the empty doors. It doesn't matter which empty door you land on, the host will open the other empty door. There's only one. He's not going to open your door. Once he opens that empty door, the other door that's not open is the one you will switch to, will have the car. So 2/3 of the time switching will help you win. So you have really switched your probability. If you don't switch, you're gonna win only 1/3 of the time and lose 2/3 of the time. And if you switch, you're going to win 2/3 of the time and you're going to lose only 1/3 of the time. So switch really doubles your probability of winning. So switch is obviously a better way to go.